Here a person is going to push a 50-kilogram crate with a constant force of 10 newtons. The crate's going to travel 10 meters at constant velocity. Let's first draw a free body diagram showing the forces on the crate. There would be a weight and a normal force. There would be a forward force of push. And now, because this is a crate at constant velocity, we have to assume that the surface of the crate is not smooth. And there's actually going to be significant kinetic friction between the box surface and the floor surface. So there must be a kinetic friction force acting. Let's find the work done by all these forces. This is similar to a video I had done previously, where the work of the push on the object was going to be the force of the push times the delta x. And in that video, it used the same numbers as this one. The only difference is in this one, there's friction. So 10 newtons, 10 meters, it's going to be 100 joules of work done by the push. And just like in the other video, the work done by gravity on the box is going to be 0. And the work done by the normal force on the box is 0 as well. Because there's 90 degrees between these forces and the displacement of the box. The box actually moves to the right. Gravity pulls down. So there's 90 degrees between them two. So that force can't do any work. Similarly, the normal force can't do any work because there's 90 degrees between the surface that the box is moving on and the direction of the normal force. But there's one new force to consider here. It's the friction. So let's find the work of friction on the box. We need the force of friction times the displacement of the box. And this time, let's consider the cosine of the angle. So if there's 10 newtons of forward force, there must also be 10 newtons of kinetic friction here. It's the only way the box could stay at constant velocity. The box travels 10 meters. But what angle should we use? Well, we should use 180 degrees. That's because the box moves to the right, but the friction is directed to the left. And so when your displacement and your force are opposed like this, then you have 180 degrees between those two. And so that's going to make our work done by friction negative. And in fact, friction always does negative work. So how do we interpret this? What does it mean to do negative work? Well, negative work takes energy out of a system. It'll slow a system down if the net work done is negative. On the other hand, positive work adds energy to a system. And if the net work is positive, then our object will speed up. So that brings us to the final question of what is the net work on this box? To calculate it, we simply add up all the works that we found 100 plus 0 plus 0 minus 100. The net work done on this box is actually 0. And so the idea is that the person puts energy into the system by applying their force on it. And at that same time, friction takes energy out of the system. So if we were to just analyze the flow of energy, what we would have is there's a rough surface that our box is in contact with, and the box is also in contact with our hands as well. And so energy flows from the person into the system, 100 joules. But at the same time, the roughness between the floor and the box, it takes energy out of the system, resulting in no net gain or loss of energy for this box. And that's why the box stays at constant velocity. Let's look at one more example where a person pushes on a ball that is rolling toward them in order to slow the ball down and eventually stop the ball. I'll draw the free body diagram. There's a normal force. There's a weight and a forward push. And that's it. There's no friction in this situation. In this case, the work done by gravity is, of course, 0. The work done by the normal force is 0. Now we have to find the work done by the push. Well, 10 newtons of push, according to the givens. 10 meters of displacement. But what angle should we use now? In this problem, the person pushes in the forward positive x direction, but the ball doesn't go in that direction. This is the case where a cannon is launching the ball toward the person. And so the person's simply going to try to catch the ball. But the ball ends up pushing the person backward, which means its displacement is to the left. That means we have 180 degrees between them two. That is going to make our work done by the person actually negative. And so what is the interpretation of that? The person takes energy out of the ball. So to show it as a diagram here, person is in contact with the ball. Okay. And in this problem, energy is going to flow out from the ball to the person. 100 joules of energy leaves that ball. And so what happens? The ball slows down. So last thing, we'll calculate the net work done on the ball. It is simply the sum of the answers we'd gotten above. It's a negative 100 joules.